Okay, for this chapter, chapter 10, we're going to be talking a lot about waves. Excuse me. Now, there's a lot of very specific math in this chapter of the textbook. I don't care for math, and I think it makes things very complicated, especially when we're talking about waves. So we're going to skip over a lot of the equations they use and talk about general concepts because this isn't a math class. So as I said, we're going to skip these two equations. So there's many different types of waves. The first type of wave that we're going to talk about is capillary. Capillaries are waves with very short wavelengths. And let me go ahead and skip forward to that. So wavelength is the distance from the top of one wave to the other. So if you think about a typical waveform, how it kind of goes up, then down and up and down. The distance between the two tops, or they're called crest, the distance from the crest, that is one wavelength. Capillary waves are very short. So for example, a cup of coffee or water or whatever, and you blow across it, you'll see waves that are very short. Those are capillary waves. The next term we're going to talk about, excuse me, is constructive interference. It's just a really fancy way to say that when waves of the same frequency are together, they add up, right? So you can kind of think of if you have two waves and they overlap, they can add up. Now, this is important because there's also destructive interference. So if you have one wave going up and another wave going down, those waves cancel each other, right? That's called destructive. Constructive is when they add, destructive is where they cancel or make less. Deep water wave, excuse me, is a very specific type of wave that occurs in deep water. And it's important because deep water waves cannot feel the bottom of the ocean, right? There's no friction from the bottom of the ocean. So as the waves are traveling, the physics of how that wave interacts with the bottom of the ocean doesn't exist, right? It cannot feel the bottom of the ocean. This is very different than what's known as a shallow water wave. As if this is the bottom of the ocean and this is the wave, as the waves coming in, so shores are typically angled, right? So as the waves coming in, it starts to feel the bottom and it changes the way the wave is shaped, right? This is called shallow water. So we'll talk about the specific ratios of that in a little bit, but shallow water is where the wave can feel the bottom. Deep water cannot feel the bottom. And there's another type of wave, which I don't really care you know about. It's the transition between transition between deep and shallow water. And it's called transitional wave. It's not very important, but it does change. Talked about destructive interference. Dispersion is anytime anything is dispersed. So in this example, we're talking about waves. And imagine you go to a pond or a lake where it's fairly quiet and you throw a rock. The waves will start from the rock and go out. They disperse, right? Same thing if you have a handful of dust and you blow it, right? It disperses, it spreads out. Disturbing force, excuse me, is a term that's used to describe what creates a wave, right? And there's different things that can create waves, right? Wind, when you blow across your coffee, throwing a rock, gravity, the moon, right? There's many different things that create or disturbing force. I don't know why they call it disturbing. That's kind of an odd word to use. The next term, super important. I do want you to know this one. It's called fetch. Fetch refers to the distance over which wind blows, right? So if you think about wind as transferring energy to the water, the longer the wind blows, the more energy is transferred, right? So if you have wind blowing over a kilometer versus 10 kilometers, the one with the longer distance, the longer fetch, will transfer more energy to the ocean, to the water. Excuse me. Forced wave, not terribly important. Forced wave is something that is never free of what's called its restoring force. So let me find it. There it is. Restoring force. So just like with disturbing force that creates, the opposite of creating is stopping, right, or destroying. The term we use for waves is called restoring force. Restoring force for most waves, with a few exceptions, is gravity, right? So gravity will eventually stop waves. So when I blew the capillary waves in here, they stopped, right, because of gravity. Some waves, like tides, are never free from their force, right? Tides, we'll talk a lot about in the next class, are created by the moon and the sun. As long as we have a moon and a sun, tides will always exist. They will never stop as long as we have a moon and a sun. This is a forced wave. Okay? A free wave is the opposite of a forced wave. So capillary wave, right? I stop blowing, no more disturbing force, gravity has restored it, stopped it. Fully developed sea. Fully developed sea is a term used to describe the ocean when the maximum amount of wind energy is transferred to the water. So this is usually really bad weather. So if you ever watch any of the television shows with, the ships kind of rolling around in the water, and there's these things called whitecaps. I don't think we talk about whitecaps in this class. But whitecaps are when waves have so much energy, the tops of them are blown off by the wind, right? And they look white, right? So they're called whitecaps. So if you ever look at really bad weather on the ocean, you can see the tops of the waves because they're white, right? Those are called whitecaps. That is close to a fully developed sea. So that means the water has a lot of energy. It has the maximum amount of energy it can hold. A gravity wave is any wave that's impacted by gravity. Capillary in my coffee is a good example. The next one is group velocity. Not terribly important. It's essentially the when waves travel, oftentimes they travel as a group. And those, instead of measuring an individual wave, how fast it's going, you measure the group of waves. And we'll watch a video in class of this. They're called sets. So when you're at the beach, you can see different groups of waves arrive. So you'll have like a group of 5 waves, and then it'll be quiet. Then you might have a group of, say, 10 waves, and then it'll be quiet, right? So they're called sets. They're different groups of waves, and you can measure the speed of them. Interference is anytime things interfere with one another. So, opposing each other, right? So interference is kind of, there's 2 types. We talked about it before, especially with waves. There's constructive and destructive. So it's just interacting pretty much for this. Internal wave is a very specific type of wave that happens below the surface, and it's kind of cool to watch, but not terribly important. It is a type of wave, though. Orbit, it refers to anything traveling in an orbit, a circle path around something. So, for example, Earth is orbiting around the sun, right? In this case of this chapter, water travels in an orbit, right? So when you look at a wave, the wave itself looks like the water's moving, but it's not. What's moving is the energy. The energy is traveling through the water, which is the medium. Now, if you look carefully at a water molecule, imagine a water molecule. You can do this with a rubber duck or anything that floats in the water. Instead of kind of moving this way, the way the waves move, it kind of moves in an orbit, right? Moves in an orbit. And that's all that is. Now, those waves were called orbital waves, right? That's the next term. Plunging breakers. If you've ever been to a beach with really big waves, you get plunging breakers. So Hawaii, let me think, California has some. We don't really have them on the East Coast here because our continental shelf is so big or so broad. But essentially, plunging breakers are waves that are coming in and they go up and they get so high, they fall over themselves with a lot of energy. And they plunge, they fall, and they break, which refers to the wave kind of falling over itself. Plunging breakers. It's a specific type of wave when it breaks. Progressive wave, not terribly important for this class. It's a wave moves. That's all that is. Progresses and moves. Restoring force, we already talked about. Rogue wave is kind of a cool wave. It's, I don't think they're very well understood, which is kind of cool. But they're very big waves and they happen to occur unpredictably. And people think that what happens is you have different sets of waves and they all add up at one spot. So you go from having kind of small waves to one spot, they all add up. And then all of a sudden you have a huge wave out of the middle of nowhere. That's called a rogue wave. Sea, another word for the ocean. I'm not sure why they have that term here. Sea state refers to what the ocean looks like. Right, so we talked about fully developed sea a little while ago. That is one end of the sea state. That is fully developed sea. It can't get any worse than a fully developed sea. The opposite of that is flat, a lake, not even a breeze, just flat ocean, which is nice, right? So sea state just refers to what the ocean looks like. So I can't remember the scale off the top of my head, but you know, if it's a little breezy, you got a little bit of waves, it's not flat, but it's not fully developed. So it's a scale. So, you know, if you ask me what the sea state is and I tell you, you can imagine what it looks like. Should I go out on the water today or should I stay at home? Seiche, I always have trouble pronouncing this word. It's kind of, it happens in large lakes, the Great Lakes. It happens sometimes in, especially New York, I think the Toledo area. It's Lake Erie, I think. What happens is, if you imagine in a bathtub, if you're sitting in a bathtub and all of a sudden with water, and you take the water and you shove it one way, it comes back, right? And that's essentially what a seiche is. Seiche. It's essentially a large motion of water in a lake, in a confined basin. A lake. Seismic sea wave, it's a wave caused by any seismic activity like earthquakes or volcanoes, subduction, right? When tsunamis are a type, we'll talk about tsunamis a lot in class, but tsunami is a type of seismic sea wave. Shallow water wave, we've already talked about. Spilling breakers, excuse me, is kind of like plunging breakers, but instead of a very dramatic kind of break, it's more they just kind of spill over. They fall over themselves gently. A plunging breaker is much more dramatic. It's a lot more energy being transferred. A standing wave is a wave that doesn't appear to move, and it kind of stands there, right? So it doesn't really move. Stokes drift. It's a way to measure drifting in the ocean, not terribly important. Storm surge, very important. It's not highlighted though. I probably should have highlighted it. It refers to the water that is created, it refers to the height of the water created by a big storm, typically hurricanes or cyclones, because you have low pressure in the middle. It essentially pulls the water up. So if you think about, we talked a lot about gyres recently, how it's kind of a dome of water. A storm surge is essentially a dome of water too. The issue with hurricanes and cyclones is that dome of water kind of follows or stays under the hurricane or the cyclone. So when hurricanes or cyclones make land, or they leave the ocean and hit land, that dome of water comes with it. And usually storm surges are just as damaging as the winds. So if you look at, Louisiana, for example, a very low-lying state in the United States in the Gulf of Mexico, when hurricanes come, even small storm surges like a few feet have a big impact, because now instead of the water level being, this high, it's now this high, which can cause some big problems. Surf refers to the area, well, surf can mean a lot of different things, but in this context, surf means the area where the ocean is meeting the beach, right? So where the waves are breaking, right? So where you have the spilling breakers and the plunging breakers, it's kind of, I don't know why they have all these terms to describe the same thing. It's essentially the surf zone, same thing, right? It's the area where the beach and the ocean meet, and that's where you typically have waves, where you go surfing, generally. Swell refers to the fact, let's see, how do I describe swell? It's kind of if you have a storm on one side of the ocean, it generates waves, typically, with the wind. And those waves travel across the ocean. Let's say there's a storm off of Japan. Those waves will travel across the Pacific Ocean to California. Now, as they travel, the waves do this thing where they sort. I don't think we talked about it in here, but we'll talk about it in class. The waves sort by wavelength. A swell is kind of a long wavelength, right? It's kind of, if you're ever out on the ocean and it's really calm, but you kind of feel like a very slow rise and fall, those are swells, right? They're kind of long waves. Transitional wave, not important. Tsunami is a very specific type of wave that's caused by earthquakes and subduction zones, tectonic activity. So what happens with the tsunami is, in a subduction zone, one of the places going under, and as it goes under, remember this plate right here has water on top of it. As it goes under, it essentially moves that water very quickly. And when you do that, it's kind of like if you're in a bathtub and you push down on the water, you create a wave. Tsunamis are very powerful, fast waves. They have a very long wavelength and they can travel very quickly. So if you've ever been to California or Japan or New Zealand, there's a whole series of tsunami sensors. We'll talk about these. They're essentially, how do I put it? They're essentially pieces of equipment that will, because tsunamis have a very distinct wavelength, will say, okay, a tsunami's coming. And it's important because they're fast and they contain a lot of energy and they're dangerous. And a lot of people, unfortunately, get hurt and killed by tsunamis. And once you hear about them, first thing you want to do is get away from the ocean and as high as possible. Not in a building, but go like up a mountain or a hill or somewhere. Yeah, get as far away from the ocean as possible because they're very fast. A wave, what is a wave? A wave for this is essentially movement of energy, right? So, gosh, it's so hard to explain some of these things. So a wave is, we think of kind of a characteristic up and down. And for water, it's essentially the result of energy moving through water, right? So you can see the waves. It's energy that's been transferred by wind, earthquakes, somehow that's been transferred to the water and creates kind of this physical effect. Not sure I explained that very well at all. Wave crest just refers to the top of the wave, right? So that's the top. We'll skip forward a little bit. The bottom of the wave is called the wave trough, right? So you have the wave crest, trough, trough. Wave frequency is just how many of those kind of crests you have in a certain time. So 1 minute, an hour, whatever time period you want to use. Wave height, the distance between the trough and the crest, how high the wave is. Period is a measure of how fast it's going. So if you're sitting at the beach and you're watching waves go by, you can count how many go by, right? So you can say how many waves go by in a minute, and you can count them, and that's the period of a wave. Reflection is when a wave reflects off of something. It kind of bounces off, right? Just like light, just like sound. They're all waves. A wave refraction is, again, just like other waves, light and sound, it will bend, right? We'll watch a video of this. There's a famous surf spot in California called Rincon. And the wave, it's a beautiful, beautiful place. You can see the waves refract and bend around the land. Steepness refers to what's known as the face of the wave. So if you have, let's say, a wave like this, it's not very steep. But if you have a wave like this is very steep, right? And so the face refers to the front of the wave. So this is a very steep face. This is a very shallow face. Wave train just refers to a set of waves. So it's kind of like, you know, if you're out at the beach, you can see one wave, and if you look past it, you can see all the other waves, kind of like a train, right? The different cars on a train. Trough, we've already talked about. Wavelength, we've talked about. Wind duration, just how long the wind has blown, right? It could be 5 minutes, it could be a week. Wind strength, how strong the wind is. Is it blowing at 5 kilometers per hour or 100 kilometers per hour? And then finally, wind wave is any wave that's generated by wind, right? Capillary is a good example. We'll talk about those. So, excuse me, that's it for chapter 10. Let me know if you got any questions, and I'll see you in class next time.